Hello guys, in today's video we'll be solving this question of knapsack with duplicate items. You might have remembered me solving this 0 knapsack problem the other day in which we used the dynamic programming approach. This is the second pattern of the dynamic programming questions that you might encounter, and what this knapsack with duplicate items is same as knapsack. It is the exact same, like all the explanations that I did in the previous video are applicable here. Just that, just that after processing an element in the knapsack, we have the option to stay back to that particular index. Unlike the 0 1 knapsack problem, that is herein, if we have, I mean, no matter we have taken the element or not, if we have processed that element, we will go to the next index, like we'll go to the previous index and minus 1. Here also the next index, here also the next index. But here, in case we take the item, then we have the option, notice, hear this properly. In case we take the item, we have the options to either stay there or to go back an index by 1. But if we do not take the item, there is only one possibility, that is to go from that index, because we are not taking it. So even if you stay there, that doesn't make any difference, right? So if you take an element, you have two options: either you stay there only, you take that again, the repetition is allowed here. So you take that again or you do not. So that is what. Given a set of n items, each with a weight and a value represented by array w and value respectively, which I have explained in the previous video already. Also, knapsack with weight limit W, okay, the same sack. The task is to fill this knapsack in such a way that we can get the maximum profit, return the maximum profit. So, note each item can be taken any number of times. So, if you are having 50 gram of gold and 50 gram of silver and 50 gram of copper, in the previous case of 0 1 knapsack problem, like this is known as bounded knapsack problem, and this is known as the unbounded knapsack problem. So, in this bounded knapsack's case, if you have taken 100 gram of gold and your bag's capacity is 300 gram, you cannot take this 100 gram again because the item is now exhausted. You will have to move to the next item, and now you have to take 100 gram of silver and then 100 gram of copper. But in this case, you can take 100 gram of gold. Again, you can take 100 gram of. So in this case, you'll have 300 grams of gold, which will have more value than what this has. So that is the only difference. So everything is same, and we'll do its a bit of its variations in these questions. But for now, we'll just copy this knapsack code because this is the same. First, the exact function I'm copying. Fine. The only difference is if you have taken this element, only in this case, if you have taken this element, you have the option to stay there. See, I'm not changing n minus 1 here because you have not taken this element. See, the value you have taken is 0. So that means you have not taken the element. Since you have not taken the element, the only option is to go to the next index. You cannot stay there and do nothing, right? Someone else want to come at that particular point. So you'll have to go away from there. But since you have taken this, you have the chance to stay back to that index. So you can take that again. That is, the repetition is allowed. Similarly, here also you cannot take it since the capacity is of the bag is less than the weight of the item. So you'll have to go. Unfortunately, so that is it. And rest everything is same, and this will work. This will work exactly the same way. 0 N is not declared. Yeah, this is capital N. Okay, this is capital N. Yeah, this works. So I hope you would have understood the difference between unbounded and bounded knapsack. I'll repeat it again. If you have taken the item, you have the you know uh, chance to take the same item again. So that means you are not going to the next index. But you have not taken it, or if you cannot take it. Notice if you are not taking it, or you cannot take it, in both the cases you'll have to go to the next index. So that is how it works. Now there is a very similar pattern that this rod cutting problem follows. Given a rod of length n inches and an array of prices of I denotes the value of piece of length I. Determine the maximum value obtained by the cutting of the rod and selling the pieces. Fine. We have to consider run-based indexing, which we are already doing right now. We are not doing this, but we are passing the size of the array. So um, this is exactly the same problem. See, in this, the two parameters that are changing is price of I. Like no, price of I won't be changed. This will be constant. The two I things that is changing is n and the length of what? Length of the rod, right? Given a rod of length n inches and an array of prices, I hope you would have already read the question given you are coming to this video. The value of pieces of length I. So basically, if you have to cut your rod into one piece, the price will be this much. If you have to cut rod in three pieces, the price will be 8, and it goes on. So if for the 8 length rod and these price is given, the maximum obtainable value by cutting the two pieces is of length 2. If you cut that to 2, then the price will be 5 of length 2, and sorry, cutting in two pieces of length, cutting two pieces of length 2 and 6. So for 2 you'll get 5 rupees, and for 1, 2, 3, 4, 5, 6 you'll get 17. So 5 plus 17 is 22. Since one base index follows, that is why I have taken it this way. So I hope you would have understood. Code is very simple. Vector n plus 1, n plus 1, comma, minus 1, on f of, you have to pass price, you have to pass n, that is the size of price, and you'll have to pass the length, the maximum it can go is 8 inches, the rod's length is 8 inches, n inches, and dp. That's it. And then you have to simply write the code of fraction, I mean, unbounded knapsack, because you can cut the same item with the same length again and again. So that is what it means. So int f of price. What will be the base case? The two parameters that are changing here is n and length. So if n is equal to 0 or